Hello and welcome to this presentation on accelerating productivity with Java, GraalVM, and Micronaut. My name is Graeme Rocher. I'm an architect at Oracle Labs, and I'm going to take you through the agenda items today, which includes an introduction to Micronaut, an introduction to GraalVM. We'll go through the latest Java 17 and 18 features with the Micronaut framework, and we'll do lots of live coding demos. So if you haven't heard of the Micronaut framework is a modern framework for the Java virtual machine that's focused on modern workloads like serverless and microservices, but it's also a complete application framework for any type of application. It works essentially by plugging into the Java C compilation process via annotation processes and providing the user with an annotation-based programming model where they can use things like dependency injection, aspect-oriented programming, all on top of a HTTP client and server based on the NetIO toolkit. You can find out more at micronaut.io and do start the repository on GitHub. If you hadn't heard of GraalVM, it's a virtual machine out of Oracle Labs that is able to plug into the regular Java virtual machine's JIT and increase application throughput between 20 and 30%. But it's also able to compile applications into self-contained native binaries or native images, which is absolutely fantastic for cloud deployments, great for serverless because it dramatically reduces startup time and memory consumption. It also has the Truffle language framework, which allows you to seamlessly interoperate multiple different languages and implementations built on Truffle, including JavaScript, Python, Java itself. And JDK 17 is fully supported by GraalVM. You can find out more at graalvm.org. Micronaut and GraalVM have a great relationship in that Micronaut's a compilation time approach, which eliminates the use of Java reflection, runtime proxies, runtime bytecode generation, and dynamic class loading, makes it much easier for GraalVM's native image tooling to perform a closed-world static analysis of the application and produce a native image, which once produced improves startup time, orders of magnitude, and greatly improves memory consumption as well. So in terms of Java 17, Java 17 is the latest LTS release that came out a few months ago, which includes a bunch of great features for developers, from switch expressions to enhanced instance of text blocks, records, which is my personal favorite, sealed types, class data sharing, and more. Plus, in JDK 18, which just came out, we have pattern matching for switch coming out of preview, the new vector API and the parent function and memory API. So let's take a demo at how to use these features in a Micronaut application with GraalVM and Java. So I'm going to switch over to a Visual Studio Code environment here, which I have set up. And I have a Micronaut application here already set up. I'm using Visual Studio Code, but you can use whatever IDE is your favorite. If you are using Visual Studio Code, make sure that you have the GraalVM extension pack for Java installed, which includes GraalVM tools for Java, GraalVM tools for Micronaut, and the NetBeans language server. With those through extensions installed, you'll get some super productivity benefits. I can directly run my application from my IDE here. It's just a standard Java application. It has a Gradle build, a source main Java directory, a source main test directory where I keep my tests. And in terms of how you start a Micronaut application, you define a static void main method with a single call called to micronaut.run. And with that, I can start my application up directly in the IDE. And if I open up the debug console, you can see my application is up and running, and I'm already up and running as a developer, which is awesome. Micronaut also includes a testing framework, which is built on JUnit 5, but we also support Spock and other test frameworks. Basically, you can just annotate any JUnit 5 test with @Micronaut test, and it will spin up Micronaut and allow you to dependency inject components with the JSR 330 specification into your test. For example, I'm injecting the embedded application here, which is one of the interface Micronaut provides, just to test that the application starts up correctly, it's up and running. And you can see that when I run this, it executes super fast. So that's one of the benefits of Micronaut, is test execution time is so fast that even writing integration tests like this, which spin up the whole application, feel like unit tests, which makes me way more productive as a developer. So now let's talk about Java 17 features in Micronaut. So there's a whole bunch of them that are really applicable to a Micronaut application. One of them is sealed interfaces and types. So what I'm going to do is I'm going to actually create a sealed interface by going new from Java template. I'm going to create interface, and I'm going to call it book API. And this is going to be the REST API that I'm going to expose over HTTP. Micronaut is based on microservices, building REST APIs. And I'm going to use this interface to expose the REST API, but I'm going to make it sealed. Now, what happens when I make it sealed is you can see I immediately get a compilation error saying that sealed classes must have subclasses. So this is by design. A sealed class must have a subclass, and it must declare which subclasses are allowed to implement it. Now you can do that through the permits proc. So I can say permits, for example, some other class here, and then I can implement this class. But you can also do it with inner classes, which makes some interesting design possibilities. So I'm going to create a book controller type here that implements the book API and provides the logic for the REST API. Now you can note that this is failing to compile with a compilation error that's saying sealed and non-sealed or final modifier is expected. Basically, when you have a sealed interface, any classes that implement this interface must also be declared final. So I have to declare that my controller is final, which helps promote immutability and making sure that your consumers of your API are using the right patterns when implementing, for example, the sealed interface. Now, let's start exposing my REST API, and I'm going to do that with a set of annotations. So Micronaut comes with a set of annotations for doing mapping routes to HTTP requests. One of those is @get, and I'm going to map this to the root URI, and I'm going to return a list of titles. And that's going to be one of the API methods in my API. So get all the titles of the books. And as you can see, immediately now I get a compilation error because I need to implement this method in my my implementation class here that's implementing the sealed interface. So what I can do is I can return just a simple list of titles here. I can say The Stand, The Shining, and so on and so forth. And now to make this controller exposed over HTTP, the only thing I need to do is define it as a actual Micronaut controller. And Micronaut has a @controller annotation for that purpose. And with the @controller annotation, you can expose a URI that a particular controller maps to. And what will happen is when an HTTP request comes in, it'll match this URI. It'll check if it's a GET request, match the URI to the GET titles method, and invoke this code. And the results of this code will be sent back over HTTP as a JSON result. So let's see how I can actually test this and how easy it is to test REST APIs with Micronaut. So I'm going to switch over to my test, and I'm going to implement a client. And what I'm going to do is I'm going to define an interface here called test book client that extends from book API. Now, you'll see here when I try to extend book API, this is a sealed interface, and test book client is not one of the declared permitted types that are allowed to extend this book API. So I actually get a compilation error saying, I can't use this, I can't extend this API directly. Now, this opens up some interesting design possibilities. For example, maybe I only want, clients of my API to identify themselves via some declared interface. What I could do is I could create a non-sealed interface called book client that extends from book API and opens up the ability to extend this API using a different interface to the original interface declared. That makes it so now I can come over here and I can say extends book client. And as you can see that now I'm allowed to extend that client. So every client has to identify themselves with the system as specifically being a client of this API, which again is making some really interesting design possibilities for building applications. So I'm going to go back over to my test, and what I'm going to do to this interface is I'm going to add client annotation. Now, what is the client annotation? Micronaut supports a declarative HTTP client that just by adding this annotation to any interface and specifying a URI, I can define a client that uses the same methods that are defined here to perform HTTP client requests to the server, which makes it really easy to test. So now all I have to do is inject this into my test method using dependency injection, and I can make a request to get all the titles from my backend service, and I can say assert equals to titles.size to get the results back. So let's run this and see what happens when I execute this test. So let's have a look. So it executed, and I can see the results down here in the console. The test passed, all is green, and working as expected. So as you can see from the output here, we have a JSON coming back, the stand and the shining. A JSON array is being sent back from the server. It's being read by the client, and the result is being asserted by my test. And this is a full end-to-end functional test that is exercising my API, and it's working in the blink of an eye. If you don't believe me, I can change this to 1, for example, or run it again, or 12. I changed it to 12, and now you can see I get an assertion failure because that was not what the expected result was. The actual result was 2 when results coming back. So that's a demonstration of using sealed interfaces. Now, sealed interfaces also work really well with records, because sealed interfaces, records are implicitly final. So, for example, I wouldn't need to use the final operator. If this was a record, for example, I could define this controller as a record, for example, and it wouldn't have to be declared final. But in this case, records are also great for representing data transfer objects in a Micronaut application. So what I'm going to do is I'm actually going to create a new record. I'm going to go new from Java template, and I'm going to select record, and I'm going to create a new book record. And this is my record, and I'm going to use it to model a book in this hypothetical system that I'm building here. And a book, for example, is going to have a title, and it's going to have a number of pages to model a book in the system. And instead of returning a list of string, I'm instead going to change this and return a list of book. And I'm going to modify my implementation here to return a list of books instead of a list of string, like so. And this was a really long book, so we'll have lots of pages, and this was a short book, so we'll have less pages. And as you can see, I've modified my controller to instead return a list of books rather than a list of strings. Now, one of the things with Micronaut is Micronaut allows you to, for example, serialize and deserialize objects like records to and from JSON without using reflection. The only prerequisite for making that happen is you have to declare the type as being @introspected. This tells Micronaut that it's going to generate what's called a build time introspection, so that it can read and write to, or in this case, it can't write to because it's an immutable object, but it can read from the record's properties, which is really cool. And it will read and be able to serialize this object to JSON. Now all I have to do is go and modify my test, and instead of getting back a list of string, get back a list of title, and run it again. And as you can see, now I'm getting JSON responses coming back from my HTTP client. 2 JSON objects, one for the first book, one for the second book. So as you can see, when you're designing Micronaut applications with Java 17, the use of records really simplifies things. This is so much simpler, more concise, and easier to write, rather than all the Java being getters and setters, or having to involve something like Lombok. And you can also add validation rules to your records. Micronaut has built-in support for validation. For example, I can say this should be not blank, and there should be a positive number of, and you can actually add validation rules so when objects are created, they don't fail validation. Essentially, when you, for example, are binding them to a REST API. In addition to that, you can also use records with Micronaut data and Micronaut data JDBC. So the only prerequisite for that, for example, if I wanted this book class to map to a database table, is instead of using represented JSON, is I'll just add the mapped entity annotation. And this tells Micronaut data JDBC that this is going to map to a book table with a title column and a pages column. If I want to add an ID column for my record, I can do that too. For example, I can add a long ID here, and we can say that this is a generated value. That should be the ID, and it should be nullable. Now I have a full object that maps to a database entity. So how can I read and write records from the database with Micronaut data JDBC? Well, what you have to do is you have to define a repository, and a repository is essentially a Java interface, and we're going to call it book repository. And there's some built-in interfaces you can extend from, and one of them is called CRUD repository, which I'm going to extend from and provide the book type and the ID type. So CRUD repository is a part of Micronaut data, and it essentially provides CRUD operations like save, update, delete, find, etc. to perform create, read, update, delete operations. The only other prerequisite for a repository is it should be annotated with JDBC repository and the dialect that you're using. So in this case, I'm using an in-memory database called H2. So Micronaut essentially computes the queries at compilation time. So we have to feed in the dialect so it knows what format to generate the SQL in. And now I have a repository for my book. So the next step at this stage is to populate some data. So what I'm going to do is I'm going to come over to my application class here, and I'm going to make this application class a managed component in my application by adding that singleton annotation to it. What this does is it allows me to dependency inject objects into my application class. And the application class is kind of a good place because it's like a central place. That's the kind of main entry point of your application. So it's also where maybe you can put startup logic. So what I'm going to do is I'm going to dependency inject using dependency injection, the repository that I just defined. I'll create a constructor. I'm going to dependency inject it in here. And what I'm going to do is I'm going to define an event listener in Micronaut, where Micronaut has an event system where you can annotate on any method an event listener and listen for a couple of built-in events. And one of those is startup event. So startup event, as you can imagine, runs when the application starts up. So this will essentially run when the application starts up. And I can make it transactional as well if I want any operations within the context of this method to run within a transaction. So what I can do now is take my repository and save some data to the repository. And what I can do is I can grab that list of book that I was using over here before and save those two books to the database in one go, in one batch SQL insert operation. The only thing I have to do is define null for the ID, like so, to pass in a null ID. An alternative to that would be to use an additional constructor. You can actually have secondary constructors inside records. So I could actually define another constructor here, for example, that would string title in pages. And I could say this null title pages, and then I wouldn't have to essentially I wouldn't have to pass in null here. So records also support secondary constructors, but in this case, I'm just going to pass in null. And what happens here is when sci available is called, it returns an iterable of book. and it will use a copy constructor approach to return a new instance with the ID assigned for each one. In this case, I don't actually need the return results, but I don't care. What I can do now is come over to my book controller and define a repository, the same repository in my application, and I can generate a constructor for it, and I can dependency inject this repository into my controller where I'm performing my my HTTP logic, and I can return from the repository all of the books in the system I'm building. And this actually returns iterable, and this is returning list. Okay, so that's interesting. So you can actually override, to fix this problem, you can actually go override the find all method here and return a list instead of an iterable. That's perfectly doable as well. And now that should fix my compilation error. Okay, so I've now built a complete example application that is when the application starts populating some data, an endpoint in my API that is reading data from the database. This method should actually be renamed now because it's no longer called get titles. We'll rename it get books. And I'll rename this property to books. And let's run my test and see what happens now when I execute this logic. Okay, so we executed it, and now you can see when I executed it, passed again, you can see that the result coming back in the JSON down here is essentially has IDs assigned to each entity because we're reading objects that are actually stored in my database. They're actually database objects that are persistent and part of the database. So that's really cool how records can be used to represent database entities in a simple data mapper approach. I would say that records are not a great option for JPA because JPA implicitly requires mutable objects, the creation of proxies and so forth. But for data transfer objects in a simple data mapper like Micronaut Data JDBC, it's a really great approach and it works really well together. Okay, so what else cool can we demo in Java 17? So that there's so much. One of the things that is really cool as well about Java 17 is enhanced instance of and switch expressions. So I'm going to imagine you have an endpoint here where you have like a type and ID variables. Inside the URI, and you wanted to return some kind of description of that type. So the type and some kind of a long ID. So something along those lines. And I wanted to implement this abstract method. Now, we don't know actually what the actual type that we're retrieving from the database. Imagine, for example, we had another repository here called author repository. But what you can do with a switch expression is dynamically decide on the type that you're going to invoke. So book repository, for example, here extends from CRUD repository. And what we can do is something like this, where you can say switch type case book, then return this repository, otherwise default null. And you can actually assign this to a repository variable. Like so. Oops, I'm missing an error. And now we have a we should probably let's call it chosen repository to disambiguate the field. And now we have a repository, and what we can do, as you can see with the switch expression, is you can pass into any switch statement, anything you can switch over, and you can provide cases that use this arrow syntax that actually represent the return result you can assign to a variable. And this is a really nice improvement over previous approaches to, having to write methods every time you want to have this kind of dynamic behavior. And of course, I'm using var here as well, which is fun. And what we can do is we can say find by ID or else null. Now imagine this was an object that came back, right? Like so. Because we might have another case here where we had case author, and over here we turned this to author repository, and it was a completely different type. We don't have that in this case, but just hypothetically, what you can do is you can say if object instance of book B, then return B dot type title. Instance of B dot title. Otherwise, return null. So as you can see, you can define these kinds of really slick instance objects where you declare on the right-hand side of the instance of a variable name, and we can completely avoid the cast and just return b.title. So you no longer have to have instance of b, then assign it to b, then cast, etc., and then call the method. Just using pattern matching here and enhanced instance of, we can easily deal with this kind of dynamic behavior a lot easier, which makes it really slick to build these kinds of applications. So enhanced switch and enhanced instance of switch expressions are really a really cool feature of Java 17. Okay, so and fine, to top it all off, when you're all done and dusted, you can take this application and you can build it into a native image with GraalVM. And that whole process will take a little bit of time, but you essentially can construct the object into a native image and compute it and run it natively, and benefit from all the startup time as well as all the great features of startup time improvements, as well as all the great features of native image. Okay, so how do you get started with JDK 17, GraalVM, and JDK 18 and Micronaut? So you can grab GraalVM plus JDK 17 builds from graalvm.org/downloads. You can head over to Micronaut.io launch to generate a project today. You can open the project in your favorite IDE. I demonstrated Visual Studio Code, but it works great in IntelliJ as well, and other IDEs. You can check out the documentation for the Micronaut framework at micronaut.io/docs. You can check out the GraalVM documentation at graalvm.org. And of course, JDK 18 documentation as well. Most of the features I demonstrated work in JDK 17, but JDK 18 has some great improvements to switch expressions and pattern matching for switch, and the vector API and so forth, in addition to all the goodness of JDK 17. And you can just start developing and feel productive with these awesome tools that are provided to all these other great open source technologies out there today for building slick applications. So as you can see, in version 3 and above of Micronaut framework contain awesome support for JDK 17 and 18 features like records and sealed classes and so forth. And records in particular are a huge favorite of mine. They reduce complexity, promote immutability, and lead to more concise code. But I really like the possibilities of sealed classes and how they make it possible to control encapsulation and how your API is extended. And then, of course, like switch expressions and pattern matching are just like amazing from an expressiveness and readability point of view. I think those are a big deal. And then there's things that I didn't have time to cover, like class data sharing, which allows you to boost startup time for JIT mode by essentially creating a shared data archive for improving startup. But of course, if you really want the ultimate of startup, do compute your application into a native image and run it natively with Micronaut and GraalVM. and enjoy Micronaut, GraalVM, and Java, and all these awesome technologies. Thanks so much for your time, and I hope you enjoyed this presentation.